let's go over some of the, I said top 10, I don't know if I counted, but talk about some things for the FRQs. And you can apply this to other things. So I'm going to just go through it a little bit. I'm going to go very quickly so you have a detailed thing of the problems. I'm just going to go over the issues. Read the question carefully. That's number one. Top 10 thing you're doing wrong is read the problem carefully, because many of you, it says average rate of G from -5 to 5. And how many times did I see f of 5 minus f of 1, -5 over 5 minus -5? Well, it's the average rate of G. Those should be G's. To me, that's a simple fix. Read the question carefully. Find the instantaneous rate of change of G. What does that mean? That means G prime of 3. Many people found G of 3 or F of 3, or this is actually F of 3, F prime of 3 rather. And so it's like, read the question carefully and do what it says. In addition to that, okay, look, like letter D. So many of you, there were things that it's like, I know you knew more than what you got, but because of how they did the points. Remember, read the question carefully and do what they say. Find all values in the interval at which G has a critical point. So you do what they say. Boom. G has a critical point when G prime, blah, 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 blah. Okay. Also, pay attention to the interval, because notice the equal signs that are not there. That means you're not concerned with -5 and 5. It didn't say equal to. Critical points and are not endpoints. Okay, you're getting confused. Remember, candidates are endpoints and critical points. And you have to find those when you're finding the absolute max or min. That's not what this question asks you. Do what the question said. Find all the x values in the interval. Pay attention to the interval. -5 and 5 aren't in there, which G has a critical point. So G has a critical point when G prime equals 0 or undefined. So you get your things. Then you write them down, because find them. So that's going to be points. Classify each critical point as a location of a minimum, local minimum, maximum, or neither. Justify your answers. So many of you had this part right. You said it negative, at x equals -2 was going to be a neither, and x equals 1 was going to be a minimum, but that's all you said. You have to justify whether this was there or not. If you're doing curve sketching, max, mins, POI, concavity, increasing, decreasing, you have to justify. And you have to use the names. Okay? You have to use the names. Don't say the word it. Don't say the word graph, because some people said G has local max, or min, I guess, at x equals 1 since it changes negative to positive. It or the graph. Neither one of those will get you credit. And that's sad, because you know what you're talking about. That's what I'm trying to do here, y'all. Every point is important. And how sad that you're not getting the points for something that you know over these little bitty things. So that's what I'm trying to do. I'm trying to clean up the little bitty things. So don't say it. Don't say the graph. G has a local min at x equals 1 since G prime changes to da-da-da. You name the graphs. Name them. Name them. Okay? So what things did we talk about there? Read the problem carefully and do what it's asked. Do everything that they say. 2, pay attention to the intervals. Okay, critical points are not endpoints. Justify all things. Don't say it or the graph. So I think that was like 5 things, but okay. All right. Again, I'm trying to make this fast. Number 2, the thing I want to say about this is kind of similar. Again, I was surprised at well, let's just do this. When it says using correct units, interpret the meaning, guys, some of you didn't even do this part. Now, maybe you didn't know it, or you just, oh, I forgot to do that part. Again, read the question carefully. Approximate g prime of 3. Do that. Using correct units, interpret the meaning of. Remember, when you interpret the meaning, you have to have your 3 things. What it is in the context of the problem. So in this case, it's the rate at which the rate was increasing. In what units. Okay, remember, when you take the derivative of something, you're dividing by time. So the units of g were feet cubed per minute. So when you're taking the derivative, that's divided by another minute, so that's feet cubed per minute squared. So what it is in the problem, specific units, put the units in your interpretation. Even if you've labeled this with units, put units in your explanation. And then specific time interval at t equals 3 minutes. Okay? If you're doing an integral, from t equals 2 to t equals 5, whatever the case may be. But you've got to have all 3 things. An interpretation is worth 1 point. You forget one of those things, you don't get that point. And you know it. It's just a matter of writing it down. So make sure you do that. On letter B and C, I think the most missed things on there were units. Okay? If units are in the question, you should put units. If you're putting a numerical answer, you should put units on it. And a lot of you, which I loved, your Riemann sum, when you wrote that out, I love it that you didn't find the big number. You just kind of left it as, 1 times 15.1 plus 4 times 20.5. I'm not going to write it all, but you had plus, plus, plus. That's great. But at the end, you need to write units. Cubic feet or whatever. So make sure it's very that's the only bad part of leaving it long like that. People tend to leave off the units. So make sure of that. So remembering units. Remember, if you don't know how to do a problem, make up something. Make up something, write a number, and put some units on it. You never know when the units is a point by itself, because sometimes they are. On C, make sure that you are not wasting time copying the whole equation. So like on C, you had to integrate W of t. Friends, just write 0 to 8 of WT. Don't forget your DTs. So that's another one. Don't forget your DTs. But use the name right here. Why are you wasting time copying all that down? Okay, especially if you have a little bit harder of equation. So use the names and don't forget your DTs. All right. Number 3. With number 3, I'm going to talk about A and C the same, or kind of together. If you read carefully, number 3, it says use the line tangent to the graph to approximate. The second, and now look at letter C. I don't want to go to that screen because it messes up the video. It says solve the differential equation. That's 2 different things. Okay? When it says use the tangent line, the second you see this, use the tangent line at t equals 0, my brain goes, oh, I got to find y of 0 and y prime at 0. I need a point, I need a slope, I need to write the equation of a tangent line and then use it to approximate. So I think you could have gotten those points. Now, one thing hugely in letter A was notation. On this one, I saw this a lot. dy dt is equal to, and you were doing the right thing. You were like, oh, okay, I'll plug in 10 right here and get -2. Now, what's the problem with that? The problem is that's a notation error. It's a presentation point. Even though you're doing the right thing, dy dt is not always negative 2. That's not true. It's kind of like a linkage error. Those things are not always equal. So you have to make sure that you either use the notation y prime of 0 or you write dy dt evaluated at t equals 0. You've got to write down that evaluation. If you're evaluating at a specific number and getting a number out, you need to write that down. Although it was not this problem, that's also true on related rates. So like when you're solving for the given rate, and I'm just totally making this problem up, so find the rate, the height is changing when the radius is 4. Well, if you get down to your your answer and you put dh dt is 3, centimeters per second. Now, if I were you, I would just write a sentence. And that's what I had you do when you were doing it in the unit. When the radius equals 4, I use the wording of the problem. When the radius equals 4, the height is changing or increasing, since it's positive, at a rate of 3 centimeters per second. You either write a sentence. That would be my suggestion, because most people forget to do something like that. You can do it there, but I think if you write the sentence and use the wording, like again, the complete sentence from the problem, you probably will get that point. So watch that notation, okay? Evaluating derivatives at a specific place, you have to say what you are doing, okay? Let's see, go to part C. Now, find the expression by solving the differential equation. If you are asked to solve, that's where you go, okay, that's where I need to separate the variables. If you see this, like that you're asked to solve it, not you can solve the differential equation, blah, 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 but you're literally asked to find it, your first step is, of course, going to be to separate the variables. So make sure that you at least do that. A lot of you, unfortunately, missed the problem because you separated wrong. Integrate carefully, and let me show you. I'm not going to write it all out because I am trying to make this video short. But many of you, this is what I saw. Work in a vertical motion, and then I just saw C equals negative 1/10, okay, or whatever. Where you went, okay, if I plugged in 0 for t, I should get out 10. So for, y, so okay, it's negative 1/10. I get it that you can do that in your head. You are smart, intelligent people. I get that. But I want you to use the initial condition. Even though you can do it in your head, I want you to write this out. Show them that you are plugging in the initial condition and then getting your C value, etc. So write that out. Please do work vertically. Some of your work, it was like you'd go here and then you'd go over here and then you come down here. Your grader has got to follow your thought process. Guys, go down. Go one line to the next. You can't explain it to your grader. They have to see the logic in it. So just work vertically. I think that's it. I did that pretty fast, I think. So those are just some things I want you to get better at. Again, if you read my, those live sessions that AP is, that they're on YouTube and they're practice exams and then they're going over it, I cannot emphasize enough how much I would do that. So I just wanted you to have these things maybe before you did that so you could maybe practice them as you are doing those practice exams and future free response so you get in the habit. All right? Y'all work hard. Work hard. You're in mile 25. You're not quitting the marathon in mile 25. You suffered enough through the first 25 miles. So by George, don't quit now. Okay? Give me one more week and we will party after that. All right? Love you guys.